Okay, so organic ones I like because it's not really organic. It's about other things like bonding or IMFs or things like that. But it uses it in the terms of organic, and we know organic very well. So I want to go through this problem. It's an older problem, but it's a really good one. It goes through some specifics and some things that we need to make sure that we are reviewing in general. Okay, so here we go. Using the information in the table above, answer the following questions about organic compounds. So you're given 3 of them: propane, propanone, 1 propanol. And you have the formulas there, and then they did give you an enthalpy of vaporization. If you're ever confused by that, by the way, vaporization means I'm turning into a gas. So this is a liquid to a gas. That's how much energy it takes to go from a liquid to a gas. You might need that later. Okay? Reminder, please be doing this to the right side. Don't be squeezing it in. Writing it fresh. Writing it from scratch, please, as much as we can. A, for propanone. I, draw the complete structural formula showing all atoms and bonds. Now, it does not say dot. So I'm going to let you do this for a moment. Hint, these are organic compounds. Hydrocarbons, carbon chains. Okay, start with carbons. Please, though, do not do this. I will start this. Do not do this and then leave it and think that's acceptable. That's when we're going fast through a lot of notes, right? You need to write every atom. It even says, show all atoms and bonds. It's not an interpretation, okay? So try to write it out if you can. See if you get it right. Worst case scenario, you're wrong, and we fix it. If you want, you can go to double I right away. I'll get to it in a second. Those formulas are written in a certain way on purpose. Okay? When in doubt, make a complete carbon chain and then add everything else. If it doesn't work out, then at least you figured out, oh, I need to put something in between those carbons. Make it like an ester or an ether, something like that. If you're not remembering all those terms, it's okay right now. The trick is the O. What's up with the O? Anybody confident in what they did with it? Double bonded on the middle, right? So it should look like this. This is a ketone. If you can remember that, that only helps you. A ketone is like a big key, like I'm going into a big door, so when I grab that, that double bonded O is like that key. Okay? That's just one point. Again, I's, double I's, triple I's, we keep talking about this. They relate to each other. I like double. If it goes up to a triple I, it's my favorite. Because then that means usually the first 2 I's are pretty straightforward and pretty simplistic in the ideas. Now, if you don't remember something, it's tough. But they're related. I'm not looking around for everything. So this one's related to the previous one. It says predictive approximate carbon to carbon to carbon bond angle. Don't be confused by that. Carbon to carbon to carbon, that means that the middle one, the center atom of anything ever written like that, is what I'm looking at for the angle. So when it says carbon to carbon to carbon, well, then it's this carbon right here. So what I'm imagining is most test takers look at their structure and they get this wrong. You're not thinking in terms of that. You're thinking in terms of what? How do we always figure out angles or geometry or anything? I'm looking at polarity. Yeah, that ultimately, if it's polar or not, will help me decide somewhat of the shape. But the shape is determined by what around a certain atom? Maybe the structure, the molecular geometry. Maybe like, what word does he want? I'm looking for how many electron clouds it has. That's how I get to the geometry. That geometry then helps me figure out polarity and structure and all that, okay? So don't forget that. Clouds. What are clouds? Clouds are single bonds, double bonds, triple bonds, and lone pairs. They all count as one cloud in each area. Okay, so I have 3 clouds. So what we need is the angle. So what shape would that be? 3 clouds would be trigonal planar, which would be 120, right? finally got a point. So there you go. And either you got it or you don't, but that's where it's at. Okay, letter B. I struggle with this because it's not a good question, I don't believe. And if AP board is now listening, I'm sorry, but you could have made this better. It says, for each pair of compounds below, explain why they do not have the same value for their standard heat of vaporization. You must include specific information about both compounds in each pair. Okay, obviously they don't have the same. A better question would be, explain why one has a larger or smaller amount of heat of vaporization. Let me just translate that first. The bigger the value, what it means is more energy is required to break apart the molecule from a liquid to a gas. Right? We're overcoming what? Bonds, specifically IMFs, right? Phase changes. That's what I'm going to write right here. This is a phase change. Phase change that's the hidden part of this problem. It doesn't just jump out and say, hey, in terms of IMFs, man, that's easy. When they do that, hey, in terms of intermolecular forces, thank you. Because then I just got to come up with, is it H bonding? Is it London? Is it dipole-dipole? Good to go. So basically, I'll tell you right now what the answer says. It says this one has this, and this one has that. So they have different heats of vaporization because they have different IMFs. It's like, yep. The bigger the number, the stronger, the weaker the IMF. The stronger. Remember, enthalpy is basically temperature or heat. I mean, that's what it really is. It's heat flow. So it is a measurement of energy. The more energy it takes to overcome those forces. So that would mean it would have to have a stronger IMF. So this is all you really need to do. Is basically you need to list them both and say that's why, because they have different IMFs, they have different enthalpies. So let's do that. Let's name each of them. So what I'm going to do it in order. So it would be a sentence, but what does each of these have? So if you could right now for me, just do an order. So like propane, comma, whatever, propanol. And then propanol will be the same again. And then what does propanol have? So please list the strongest IMF you think is present in each of those. And then what you would have done is just saying, because they have different IMFs, they have different enthalpy of vaporization. I had a much more elaborate explanation last hour. I was saying this one's a stronger IMF. That's why the enthalpy would be greater, because it would take more energy to break them apart. Yes. And then I read the answer. It was not that. It's just this has this, and the other one has that, and they're different. That's why the H's are different. Yep. So what you have to do, though, you have to look at this, and without really drawing them out, you should be able to identify. Reminder on this. If it's nonpolar or polar, that's where I go first. Right? Is it symmetrical or asymmetrical? If it's symmetrical, that's one thing. If it's asymmetrical, then does it have something inside of it or not? Does it have a certain type of bond or not? And that's what we're about to answer. All right. So propane is what? That is London. That is LD. Right? That is completely symmetrical, right? That just looks like this. Right? There's nothing else there. This one, some of you might have gotten wrong. So let me redraw before I even hear the answer. If I redraw the one we just drew, they asked for the shape for a reason. There's always a reason for a lot of this. This is actually what the shape looks like. And I could draw more, but that's the shape. So there's no H bond, right? Because you have to have fun with H bonding. H with F over N. So what is that? It's a dipole because it's polar. It is polar. Right? That's not a linear shape. There's definitely some unevenness. This would be pulled up like that. So the minute I figure that out, this is dipole-dipole. So automatically, this is dipole-dipole. And what's the last one? Hydrogen, right? Propanol. Oh, I don't remember that. That's okay. It's right there in the formula itself. OH at the end. OH always at the end. That's definitely hydrogen bonding. That's H bonding. So I know it's unrelated, and by the way, that's 2 points, one for each set. Does that make sense though with the enthalpies? I hope it does. Like the largest enthalpy has the strongest IMF, right? The smallest enthalpy has the weakest IMF. That should make sense. It doesn't make a ton of energy to break apart the weakest attractive force. At least I hope that somewhat clicks. Okay. So it's good to just bring that back up. Letter C, draw the complete structural formula for an isomer of the molecule you drew in part AI. Okay, so you're like, oh God, what's an isomer? So this is the test. It's if you even remember what it is. Of anybody who's going to remember, it's us. Because we actually had on our test and on our worksheet, I gave you a formula, if you remember this, and then I gave you 12 slots, and I said, go. And all you walked out like, how many did you have? How many did you have? Oh my God, I only did 2. I made extra slots, which I'm like, don't. So what did we do? We moved around bonds, right? And we move around functional groups. So idea, and I'm just going to get you started. I want to see if you can do this without me. A good idea would be to draw the main structure of it. So what I would do is draw the carbon chain first. And can you do something else with it? You only have to do one. Now, here's the trick. You need all the same amount of H's and O's yet, right? So you could either add extra bonds between your C's, or you got to move something around and maintain everything else. So are you able to do this? I'll give you a minute to try it out. Give it a shot. But if you didn't remember an isomer, you might just be stuck. So I'm going to pause it as we work on this. What did anybody do? And H's go last. So what did someone else do with an O? You put on the first one? Like double bonded O? Okay. So if you do that, don't make life hard. Every C has to have 4 bonds, right? So what I would do is just go through first, go, okay, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And then I would just double check, okay, so I had 6 H's, 1, 2, 3, 4, 5, 6. Sweet. Don't forget to put them in. Anybody remember what that actually is, what functional group? It's not the question. It's a little guy sitting at the edge of a cliff. Fall, there's a shark waiting. And when he dies, you're going to have a service for him and fill him up with, oh God, don't fill him up butane. You can fill him up butane. Formaldehyde. So it's an aldehyde. An aldehyde is when the double bonded O is on the end. Formaldehyde is just a certain number of C's. That smell that you ever, for a specimen, like in biology, if you ever did like a pig or a worm or anything, it's hard to explain, but if you smell it, you're like, okay, that's formaldehyde. Yeah, it's a preserving. It's also very toxic. It's not good for you, but it preserves tissue in bodies. Okay, 1 point. Whoever's listening to this, like, what are they doing? Given the structural formula for the propine below, oh, I love this. Give me a picture and then have multiple questions about a drawing. Yes, I can do this. So indicate the hybridization. Big word. Of the carbon atom indicated by the arrow in the structured above. I love the arrow. It's like someone had some fun. Look what I did. Okay, Jimmy, we'll leave it on there. Just for you. Okay, does anybody remember hybridization? It's when you take all of your different sublevels, your S's, your P's, your D's, and you got to make one new one. Okay? You will never have to explain it because they can barely explain it. Okay? You just have to come up with the lettering. So, for example, if you had 6 clouds around there, what did we do? Well, let me just do a little quick education on you. Is that these are all the possible orbitals. And you take electrons from each one, and that's as many as they can give. So for example, if you had 6 clouds, or 5, 6, we would have said S, P, 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 D, D. We'd say S, P, 3, D, 2. And when you were in the middle of this was like, oh, I got this. But now we got to just remember this. So in this case, it's still about clouds. I have 2 clouds, so I'm going to say S, P. If it was 3 clouds, just so I hear it, the audio would be SP2, right? SP2, it'd be 3 letters. It's you know it or you don't. It's one of those things that can you remember it? Gosh, I hope we would remember something like that. Okay, so that's I. And that's just 1 point. Double I. Indicate the total number of sigma and pi. Okay, again, do you know it or not? I'm going to try to just let you free. So pause it, give it a second. I'll give you about 30 seconds and you know this. think they have it. They already have that app.
Seriously? Well, why don't I have it?
And anyway, on a Google map, you could just hit mark.
So crazy.
Yeah, they already do have that, which is really smart.
They do have that app? I did not know they had that app. That's
Sigma. So every bond is a sigma or a pi. Every bond is a sigma or a pi, like the location of the bonds. Every bond has which one? Sigma or pi in it? Sigma. Sigma is strong. Sigma is single. Sigma holds the initial bond. So when I see this, I see 1, 2, 3, 4, 5, 6 areas of bonding. That's why it's 6 sigma. But every bond line has to be accounted for. So when you have this triple bond, this is a sigma right there. And then you have these orbitals above it that reach, and those are my pi's. And why you can only have a triple bond is because, I just have to show this to you. If I have my sigma here, I can have a pi bond above and below, then I can have a pi bond in front and back, and there's no other space. I can't have another bond. I can't have it like at an angle. It's done. So that's why you can only have a triple bond. So there would be 2 more pi bonds because there's 2 extra bonds. Pi bonds are extra bonds. A triple bond's not 3 pi bonds. A triple bond is a sigma bond and 2 pi bonds. The big hint for me, always for you to tell you, is that these together need to equal every bond line. So if you count 8 and you only have 7, better redo it. Okay? Crazy. I'm not kidding. 2 points. I mean, I think that's amazing. If you could get that, it's just be like, thank you, AP board. So that is my orgo one that I wanted to do for you. Let's get to the nuclear one. We're going to go through this kind of quickly. Half of it's nuclear, half of it's kinetic. So it's actually good to get a little review on this. Since 1999, this is the most nuclear in a free response there is. Okay? I know it says 2003, but since 1999, it's the most. So here we go. Please take it for what it's worth. Again, understand that it's not like, whoa, its time has come. It's going to be here. I'm going to say it's not. I'm going to lean that way. Watch, it's like 3 of them. The decay of the radioisotope I-31. There are some things, though, to talk about. So I-31, what is the 31? So if you look at iodine, what does 131 mean? Yeah, go. If we're talking about the app, no.
No.
Okay.
All gonna take the same test. Or they just, or do you not know?
I don't know, but once in a while they'll throw in some random ones as other testers, but I'm assuming you're all taking the same one.
Okay. I mean, not like I plan on cheating, just curious.
What's the 131? It's the... No. So the atomic number is 53. So it says 126.9 on the periodic table, but this says 131. And that's true. It is. An isotope is an atom with different masses. No, it is iodine. It's iodine. I was so confident like 3 minutes ago. Those are mass numbers, though. Guys, so an isotope has different mass numbers. So when you would say like carbon 16, if you look at carbon, it only is a 12. Well, where the heck did 16 come from? There's radioactive ones that meaning they're not very stable that weigh 16. Most of them weigh 12 and a little bit of 13. But there's a few that are 14 and 16, for example, for carbon. So I just want you to know that this 131 is the mass. Okay? It always says it like that. You say the atom, and then you say the mass number. All right, so here we go. It says, is known to decay by beta emission. Even if you're like, oh boy, we barely touched this, I don't know how to do this. I think you can do this. Write a balanced nuclear equation for the decay of I-131. So let's take a look at that. So what I have here is you write I. Reminder that the mass goes on top. Why I'm talking about this here is that they give me 2 numbers, so I'm feeling like I should do this. Technically, it's redundant to write the atomic number in the lower left. Why is it redundant? Because you're already writing I, so a lot of times you won't see that number because it is already 53, but that will help. So you put the mass on the top. This is the mass. So that's protons and neutrons, and this is just protons, right? It says decay, so that means it breaks down immediately. It says there is a beta emission. Even if you're very confused by that, that has to be created. So at this point, you guys, all this is simple math. The top numbers need to equal each side, from each side, and the bottom numbers need to equal each side. So if I have a 0 up there, this has to be 131. What does that bottom number need to be? 54. So what atom does this become? Right, because of the 54, correct? You were just ahead of me. You're just ahead of me. You're foreshadowing. Any good story needs that. Okay? So that's that. 1 point. We need to speed this up just a little. What is the source of the beta particle emitted from the nucleus? Please understand this. All nuclear decay, that means that a nucleus is breaking down. And what's inside the nucleus? Protons and neutrons. So if you're ever going to guess something, it's protons and neutrons. But let me help you out even more. What's the difference from one isotope to the next? If I have an isotope of carbon, and I have a different isotope of carbon, and a different isotope of carbon, what can only be the difference? Protons and neutrons. It has to be neutrons, because if I change the protons, I change the atom, right? Protons are the identity. So we're going to leave it at this. It's the neutron. And I'm moving forward with my life, okay? I'm just telling you right now. But I'm not going to go into it further. I'm gonna roll the dice on 20 years of just graphing this out there. We're moving forward. Okay, letter C. You should be able to do this even if you're like, I don't know like this is not really all that much nuclear. But if you're freaking out about nuclear, just slow down. Determine the half-life of I-31 using the graph above. Okay, can anybody in their own words, and not very lengthy, explain to me what a half-life even means? You flipped it. Say it again, Maureen. Okay. So, yes. Let me ask you this. If something takes 50 years for a half-life, it's 50 years, okay? And let's say you have 100, well, it doesn't even really matter. How much is left after 100 years if you have a half-life of 50 years? Quarter. It's not all gone? That's what normally people will say if you don't think slowly enough. Oh, half it's gone in 50 years, the other half's gone after that, right? It's half, and then half of that, 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 right? It's never going to actually be gone if you're talking about a half-life. So slow down on that. They'll trick you on that. So just slow down. If you're given data, though, it's not difficult. Pick a spot. They made this one easy. How long? What's the half-life? 8 days? First off, look at the unit. My gosh, look at the unit. Oh, it's always seconds. It'll be 8 seconds. Yeah, look at that. That's half, right? And then check this out. That's half. And then that's half. And every time it's 8. So it's 8 days. Done. By the way, both these are 1 point. That's all you have to do for that. Okay. D. I like this problem because it does get into kinetics, and kinetics does link with nuclear because of half-lives and things like that. The data can be shown that the decay of I-31 is first order. Please underline that, circle that, highlight that, whatever. As indicated on the graph below. Ooh, I, double I, triple I, I'm excited. And I really am. Whenever I see something like this, I actually think that I have a good shot at these. And if it's going to be hard, usually the triple I is going to be the most difficult of the 3, but not always. Label the vertical axis with the graph above. Can anybody, without me saying, hinting, yeah, Evan? Yeah. Now, if you're really technical, it should be of the concentration of your substance. So it should actually be of that. Now, I'm going to go off the beaten path for a second here, and you might want to just write this down anyway. What if that exact wording was said, but each of those graphs were given? You should still be able to give me the proper label. You're like, well, I can't, they're not straight lines. Hold on. It says it's first order. So what would this one have to be then for my label? Can anybody pull that out of their brains? Huh? Because what is this signifying? This graph would be, this is a 0 order, but it's not 0 order because it's not straight line, right? But it's still a negative slope. This one is going positive, but it's not straight, so this graph would be 1 over. So it's showing second order, but it's not. So you're like, well, I don't get it. if it tells you it's first order and it's not a straight line, you still have to be able to graph it. You don't just blindly go natural log. I did that on your test when we did kinetics, where I said it's first order, and then I had this. Oh, wait. Okay, if it's first order and it's not making a straight line, it's a negative slope. First and zero orders have negative slopes. Second has a positive because it's flipped. So that's what I would have to give if that was that graph after being told it's first order. And this is the one I'd have to give. It was second. Now, if they said it was second order and they had this, the top one, that's a really unfair question because it could be first or zero. You know what I'm saying? Like if they said this is second order and then they give you this graph, what? So they would always give you, they would actually say zero first order and then they'd give you one or the other. I know I'm going above and beyond that, but that it was a good opportunity to talk about. So that's I. Double I, what are the units of the rate constant? Okay, this is kind of, can you pull that out or not? And the reason why I say that is that you're not doing any other calculations, so you don't have a lot of help with this. So if you can remember, rates equal, I'll just write this out once. Rate equals a K times a concentration. Translation, it's molarity over time equals K times molarity. So you need one less of the overall order on the right side, so then it gets rid of all the molarities but one. Okay? And I know that's probably sounding really confusing, but even when we were in the chapter, it was confusing for some of you. So what I do is I take liters over moles and I put the exponent one less than the overall order. Translation, in this one, I meant first order. Okay? So all I need is, I don't have an exponent, it's just one. So I already have molarity there. So all I need is inverse time, because then I'd have molarity over time equaling my molarity over my time. So what is my unit? 1 over days. I just need the time. I already have the concentration. So it's 1 over days or days inverse. One or the other. Just let's say it was third order overall, it would look like this, just so you remember this. That would be third order for K. See what I'm saying? Like it's one less than the overall order, and I flip the molarity, and then it's times the time. Just as an example. We'll get back into kinetics again. That's kind of hard to remember, but it's only a point if you got that one or not. Triple I. Almost done. Explain how the half-life of I-31 can be calculated. Now oh my God, they're going out of their way. Using the slope of the line plotted on the graph. Remember, you get your orange sheets, which won't be orange. And we do need to talk about that, and I will remind you again, but you can't rip them out. They're in a book, and apparently like 6 people last year ripped them all out. I never knew they were stuck in a book. You actually have to go back and look every time, which doesn't make any sense to me. And Mr. Anderson actually had to write special letters to make sure their tests were accepted. So do not rip it out. We will talk about that probably every day for the next 12 days. So what is the slope? Anybody remember? Yeah, that's true. Rise over run. Good. I cannot disagree. It equals what specifically? K. In the y equals mx plus b, that's the K. Technically, in this one, then slope equals negative K. So if it says, how can you do the half-life? I see Ben grabbing his orange sheet. You're going to have it. Ben, what does it say on there?
T half equals 0.6935 K.
Yep. Let me just tell you what you'd say. You'd say, knowing that the slope equals negative K, you could utilize this equation. Done. Check this out. 1 point for saying this, 1 point for using that. Does it actually say calculate it? No. How could I calculate it? I have no rise. I only have the run. I believe that's right. So they purposely do that. They don't give you, if they gave you numbers, I know everyone would do it. Well, actually, what it is this. And then you'd actually have it, and then you're not doing any. You're not actually showing any disadvantage. Final thing, and we'll move on to our new problem. Compare the value of the half-life at 25 degrees to half-life at 50. I'm just coming out and telling you this, okay? This has nothing to do with K, okay? Just understand that, like, I'm not affecting the K for, and you're like, well, no, I totally do K for this. I understand that, but this is a nuclear decay. I'm just going to tell you. Nuclear decay is unaffected by temp. very specific question, we just aren't going to get into it, okay? Think of it this way, you know when they do like carbon dating and everything, think about what they have to take into account if that was affected by temperature. I mean, you know, that would be almost impossible. So, luckily that's just how it works. Again, we're not going to get into that. I'm just telling you the answer for that one. That's just one thing. Okay, so let's get into our new stuff today. We have one problem due today. Go to the 14, 16, please. I'm going to do the first two. You're going to do the last two. So all 14 through 16, I know that's 3 chapters. I'm only making you do 2 because I think they're all kind of together. So understand it's not like, holy cow, I got, you know, all these extra problems to do. You're just going to have to do 2 of the 4. I'll do 2. You do the other 2. All right, so here we go. We're going to finish with this today. This is a really good problem. It kind of applies a lot of things. You're going to kind of recall, I hope, a lot of the information that we've learned. There's one problem that's a little tricky, and you probably would get it wrong. And I was very blunt last hour and up front. I would have gotten it wrong. I would have said the wrong answer. It's actually the first one of all these that I probably would have. I can definitely say that I would have gotten it wrong. I would have went down a different path. So I'll show you that one in a second. So here we go. It says, answers following questions that relate to the chemistry of halogen oxoacids, which is a fancy way of saying that it's an acid with a halogen and an oxygen in it. So don't ever get thrown off by words. I hope that you're not like that. Like you see that, be like, I'm done. I'm out. I don't know what that is. Like, move forward. You're okay. Use the information in the table below to answer the part AI. So you have an acid and you have some Kas. It says, which of the 2 acids is stronger, HOCl or HBr? HOBr. Justify your answer in terms of Ka. Man, they're giving this to you. Like they shouldn't have to say that. You should actually know that already. They're very nice. So you got to just look at this now. I'd like you to take 30 seconds or less, and this is a very short answer. But which one do you think is stronger in terms of Ka? And if you're not sure, hopefully you'll remember. Think about what Ks mean. Think about what a Ka tells us. Which one's stronger? HOCl. I will agree. HOCl because Ka is larger. Right? Reminder, Ka's, the larger the Ka, that means the products are on the top, the reactants on the bottom, so that means it makes more products. Strength means how far you go to the right. That's all it means. So if I have something like this, it can be any one of these, but I have this. The stronger it is, the more it's over here. The weaker it is, the less it's over there. Okay, so the larger the Ka, the more I'm going to be to the right. Double I, and that's just a point. Draw a complete Lewis electron dot diagram. Make sure you put every single dot. Don't overthink this. Usually the formula, how it's written, is the way that it's probably drawn. So just draw it out and make sure that you put the dots. This is just probably trying to give you some points. If you butcher this one, there's not much. This is just kind of on you, even if you didn't understand the first part. What's nice is if you pick the wrong one in AI, A double I can still be right. So I'm not going to wait too long on this one. Hopefully you did that. Okay, there's nothing I can really say. Do you have it or you don't? All right, here we go. And this is the one that I got wrong. Okay. Hypoiodous acid has the formula HOI. Predict whether HOI, and you got to make sure you're answering this in the right way. Predict whether HOI is a stronger or weaker acid than the one you identified in part AI. Justify your prediction in terms of chemical bonding. So let's just look at this in general. If I had HOCl versus HOI, clearly the only difference is the Cl and the I, right? I mean, that's the difference. So that's what you need to be focusing on. The strength of an acid is what? Is it stronger if it holds the H tightly, or is it stronger if it holds the H weakly? A strength of an acid produces what? The stronger the acid, it produces more H plus, right? So that means H plus has to get away. So the weaker the acid, the stronger the H is actually holding on, and it can't get away. Fortunately, that was my demise. That's true. I'm not saying anything wrong. That was my demise in this problem. Okay? So, what's the difference between these two? It's about size and electronegativity. Okay? And this is all still right. Nothing's wrong with what I'm saying right now. It says a lower electronegativity. That says electronegativity. You just have to trust me. So what that means, what does that mean? That means it doesn't pull electrons as hard towards itself, right? So what that means for this one is that this pulls really hard to the right. Really hard to the right. This one does not pull nearly as hard to the right. So it's a much smaller thing. So this is how I viewed it. And I was wrong, and I don't want to try to confuse you, and I don't think this is going to make or break you. If you are going to get a 5, you're still going to get a 5. If you're going to get a 1, you're still going to get a 1. No one's going to get it. This I viewed it as this. It's not as strong, so it's not holding the H as tightly. That's how I viewed it. That makes sense to me. This C is really tiny. It's going to be pulling it, and it's going to be really attractive. Here's the problem. The O's in the middle. The O's blocking some of that. So what it is that the actual answer says that this H is more attracted to that O because this isn't as extreme of, like there's more electrons on every one of these atoms yet. So the H is still more attracted to the O that it's connected to than here because all the electrons and everything else are being pulled so far to the right, there's not a lot left to be able to hold on to that H. So this is weaker. HOI is weaker because the H is still more attracted to the O than the other one. I had it wrong. I would have guessed it was stronger because I would have thought that the H was not going to hold on as well because the I isn't holding it, but it's actually the opposite, is that the Cl is pulling the electrons so hard and it's such a severe polarity shift and the electrons pull so hard that the H is not really attracted to the O as much anymore. All the stuff I just said.
Less electromagnetic.
Yeah. It's complicated. The thing is, it's only 1 point, regardless, okay? So, what I'm also kind of saying is I got it wrong. Not that that's an excuse at all, but it's one of those things where sometimes you're just going to run into a problem that is just kind of tricky or you're not used to running into. All right, B. You should all be able to do this one. And I accidentally just did it for you a second ago. There are 2 ways you can do this. I don't want to give any hints, and I erased it on purpose. Can you write the equation for the reaction that occurs between hypochlorous acid and water? And if you're like, what the heck is hypochlorous acid? Probably something that was already just given to you. It's probably one of those 2. So remember, it's an acid in water. What is amazing to me as you're doing this is a lot of you are your worst enemy. All of a sudden you see in water, you're like, what? I know how to do acid problems, but in water? They're always in water. Okay, there's 2 ways you can do this. There's a shortcut and then a long way. If you're having problems, I'm giving you a hint. There's 2 ways you can do it. No matter what, this is only going to be a point. One or the other. With acids, remember, I can abbreviate it because it's just breaking apart anyway. With bases, why can't I abbreviate? Because the OH has to come from somewhere. You need the water. So when in doubt, always put water. Reminder, it's been just a little while. H3O plus is the same thing as H plus. It's the same exact thing. Okay, so that's that equation. All right, what I like about a lot of these problems, and you have to keep telling yourself this, please, for me and for you, when you're doing these, if you're having problems and you're struggling, and right now let's just say this problem is just kicking your butt, things reset. Letter C is almost completely fresh and new. So just, okay, when they start giving you new explanations, just start over. So it says a 1.2 molar NaOCl solution is prepared by dissolving solid NaOCl in distilled water. Hydrolysis reaction is that. I, write the equilibrium constant expression for the hydrolysis. So they want an equilibrium expression. What is the equilibrium expression? Bless you. That means I'm putting K and I'm putting other things. What K am I doing exactly? Look at the equation. What K is that? K B. Because of OH. Finish that up. I don't know if you would get it. I don't know if you would get it wrong if you didn't write the B. I can't tell you that. It doesn't specifically say. It says 1 point earned for the correct explanation. Sorry, expression. So hopefully you got that. Reminder, you're not doing water, right? Water is a liquid. You only need gas and EQ. Double I. And I'm not doing this problem, I'm doing the one above. I don't have space. Calculate the value of the equilibrium constant at 298. Okay, so this is where I can try to help you in the ideas of testing. I need to know B. So what would I need to have? I need all those other three things, right? Do I have those three other things? I mean, I need them all. The answer is no, I don't. I don't. You're like, no, but you have 1.2. If you're only given one thing, that means to find the other things, you need equilibrium. Either you're given all of these at equilibrium to find K, or you're given something and you have to have equilibrium expression already, or the constant. You need everything at equilibrium or the K, one or the other. So what that does for me as a test taker is I need to take a step back and go, wait a minute. Is there anything else? It's really important. If you only heard one thing today, this is the one thing I want you to walk out with. Is there anything else within the problem in general, the big problem, that relates at all to anything that I'm working with? Anything at all? Nick? Oh, so what have I been given? Yeah, I have that. If I have a K of a conjugate partner, I can get the K of the other one. Okay? And that's a small leap. You would have to recognize that, okay? So, again, let me just say it one last time, and I'm sure I'm just now repeating myself, but if you ever look at a problem and go, I don't think I got enough, slow down and say, what else have I been given that maybe relates to this problem in any way? So, this is how I'm going to write it all out, and hopefully you're going to do the same, and I've taught you enough that you're going to show your work as smoothly as possible. Whoops. So wait, I'm at problems with my K's and my KB's. So that's what I want. So I just plug it in. What's the other one? 2.9. And unfortunately, I think that's harder than telling me sigma and pi, but I'm not going to complain that they're giving me 2 points for sigma and pi. Never do that. AP gods, never going to do that. But I think locating that and figuring that out, I guess if someone would say, tell me how you want me to give 2 points for that. I don't know. Just figure out a way. No, that was a bit of a leap, I think. All right. I have a couple more left. We're doing great. Calculate the OH in the 1.2 molar NaOH. Okay, once it starts calculating, guys, read the writing on the wall. They gave you you had to find KB expression. They're making you find the KB, and now they're telling you to calculate a certain amount of one of the ions. If this doesn't scream icebox, or at least starting of an icebox, I'm not sure what does. Do yourself a favor. If you even think it's an icebox, write it out. So I'm just taking the equation that's from letter C, okay? So I'm just taking that equation. I'm going to just rewrite it out here. Maybe I don't need it all. But don't be too prideful and thinking, well, I don't need to write this out. I know what I'm doing. Set it up. So let me reread what they wrote. I have 1.2 molar of NaOCl. So what does that do for me? What do I have? I have the OCl, right? That's a salt. It's going to break up. Remember, salt, well, how do I know it's 1.2? Because it breaks up. It's a salt. So both ions are going to be carrying that. So I have 1.2 molar right here. The minute I do that, hopefully it reveals itself. What is this? This is an x squared over initial minus x, right? Now, personally for me, I'm just going to do this for you today, is that I want you to completely just see it, is that x is OH minus, right? That's the question. The question is, what is OH minus, the concentration? Okay? So, I go. You're sitting there going, well, how much would I need to show? I don't know. The icebox doesn't have to be there. You probably could just start with x squared over initial minus x, frankly. But you have the time. And time's usually not the issue on these tests. This is one point right here, just by having that setup in general. Did you understand that? And then one point is for the answer. And I'm hoping that our answers look like this. I write x equals OH minus. And if you continue on, and not all of you obviously are going to be chem majors or anything like that, but you're going to be doing some of this stuff probably at some point again. I'm assuming most professors and everybody else are going to be writing a lot of the same kind of formats. Right? Some really good professors and teachers that just really showed their work really well. So I'm hoping that that's something that you'll continue to see. All right, last part. Letter D. We have two parts, and this is not as hard as it looks. Now, it doesn't necessarily have to get harder, but it usually does, but it doesn't have to be. A buffer solution is prepared by dissolving some solid NaOH in a solution of HOCl. The pH of the buffer solution is determined to be 6.48. So it told me that the pH is 6.48. It says calculate the H3O plus. Anybody want to tell me how you do this? And this is an I and a double I. Again, that's kind of good. I like those. Yeah. Yep, so that's the same. Good. So that's the same as H plus. Good. So this is the equation I need, right? Which is also H3O plus, right? Well, if I want H plus, I need that, right? That's all. Boy, how do I know it's at equilibrium? pH is always at equilibrium. The stuff already dissolved and it moved to the right, and now I'm taking it. I'm taking the reading. So, what am I doing? pH. I forgot what I'm doing. Here we go. Last problem. Indicate which HOCl or OCl minus is present at a higher concentration in the buffer solution. Okay. It's great. This is one point. What they did is not how I would do it. This is how I would do it. This is the way that I've taught you. So if I drop this, they're talking about HOCl and OCl. What has to be present to be a buffer? Help me out with that, and then the rest of it we can figure out together. More. What has to be present for this to be a buffer? It's within the problem as well, if you just want to read it. True. Correct. Which it consists of? Water. Yeah. I'm not answering this right. To be a buffer, I need parts of conjugate partners. So it's asking which one I have more of. No, I need both of these. But I'm telling you now, I'm not asking anymore. I need amounts of each for it to be a buffer. You need a conjugate acid and base pair. Okay, if I only have one of the circles, it's not a buffer. I need both. Okay, the minute I have both, what equation do we use to find pHs all the time when I have two things? Henderson-Hasselbalch. My gosh, if you realize, they say the word buffer and say calculate, Henderson-Hasselbalch. So let's quickly write that. This is what it looks like. I don't care if it's not on your orange sheet. Try to remember it. They have a different way to do this, but this one works better with what we're doing. If it asks which one we have more of, guys, what if I just find this ratio? If the ratio is greater than 1, then I have more base. If the ratio is less than 1, I have more acid. So let's just jump in. 6 point, is it 48? That's the pH, equals negative log of my Ka, which is 2.9 times 10 to the negative 8th, plus log x. And all you got to do is solve for x. So take that to the other side, take 10 to the answer, and if your answer is smaller than 1, then you have more acid. If your answer is greater than 1, you have more base. So you have more OCl minus. Okay? And that is a total of 1 point. You can figure that one out on your own. All right, so we did a little orgo, we did a little nuclear, we did a little aqueous equilibrium today. What did you get? I got less than 1. I got something times 10 to the negative something. We'll calculate it later.